This is Mike Walt with LM3. Today I'm going to go over training an object detector using the first time training tool. So the first thing I'm going to do is go into the camera viewer. I'm going to use the cap profile. I'm just going to make sure that we have a good view of this. And what we're going to do is train on the hole, the plug, and the PNG symbol, which is a little bit faint in this picture. Let's see if we can adjust the lighting. So actually I'm going to move the camera a little bit. So let's create a new profile that we're going to call Cap OD for object detection. So we're going to go ahead and train it this way. We can go ahead and go out of this. Go back into the tools and let's do a snap and train. And we're going to call this Old Spice Cap OD for object detector. Camera 1, Cap OD for the profile. Okay, so now we're in the snap and train. And as before with the classifier, if you watch that video, just go ahead and snap an image. And the labeling program is going to open up and allow us to specify which objects we want to detect. Okay, so let's make sure that we're in not in classifier mode, which we are. We're going to call this plug. That's going to be an expected item. Hole. Expected item. PNG. Also an expected item. And then we're going to call this hinge. Okay. So we'll start there. Just going to keep it fairly simple. And we'll go ahead and close. And at this point we can just start taking samples of really any cap because we're not focused on color in this case. I'm going to move some to evaluation as I'm going along here as well. So this process is the same as before. Nothing different. I'm going to work just with the good ones in this case. You get a detector to learn what those objects are regardless of the color shade, but we'll just work with the good ones. A couple more and we'll be done. Keep in mind, if you're like running on a conveyor, you can always use the next part to index the conveyor because it'll send a signal, pass signal as a matter of fact, so that you can index different parts into your station. Obviously we're stationary in this one, so I'm just hand loading these parts. So now I'm going to load some that have a good color appearance, but if you look at the hinge, it's cracked. So I'm going to change the template on this one. So hit template, change the template, and wait for the labeling program to open, and then we'll change the label. So we still have a plug. have the hole. We have the PNG. But in this case, we're not going to label the hinge because it's bad. So we could say this is like a crack defect, which I guess for demonstration purposes, let's just do it that way. So we'll just call this crack. We'll specify this as a defective object. Crack there. And so we've created our template for these parts with a bad hinge. So let's get some samples. Move the part around a little bit. Unfortunately, I only have 3 of these. So I'm going to kind of just move them around to get more sampling. Make sure we move some to evaluation. Big cracks in this one. This one I kind of pushed in there so that the light's shining on the PNG. I think we'll leave that the way it is. But it may cause some confusion. But we'll train the detector and take a look. I'm also going to do a little bit with these parts that have like the discoloration in them, so we can mark those as defects. I'm going to create a new template. So hit template. Wait for the labeling program to open, and then we'll label these a little bit differently. So this is still a plug. And this is still a hole. And this is still a hinge. So it looks, fairly different than the other one. PNG symbol. And then we're going to call this discoloration. Call this a defect. We'll have to move these around a little bit because the discoloration definitely varies from part to part. But this lays down our labels so that we can make some fine adjustments before we do training. So snap off a few. That one appeared to have a crack, so we'll keep our eye on it and label the crack when we do final verification. We got plenty of images at this point, so let's go ahead and train. Let's go ahead and hit the train button. So the final part of the training process is just to go verify all these labels and make any corrections for parts that were loaded wrong or something was missed. So these are plug, hole, PNG, and hinge for the good ones. So since the part was moving around some, we're going to want to make some adjustment. This is important for object detectors because we're looking at specific objects, whereas with a classifier you're looking at the entire image. So these should be placed centered around the objects that you want to detect. Those look good. Just do a little bit of repositioning. We're going to keep our eye on the discoloration and any cracks in the hinge. In case some of the parts that I loaded had cracks I didn't notice. So this one's empty, so the way I suggest handling this is you want to have some labels on your image for the training system to use. Otherwise, it'll just ignore them. So I'm just going to call this nest. Really should have more than one of these, but we'll train it with just the one. And the nest is just a reference object. So we make this a reference, which means that the evaluation system will ignore it as far as calculating accuracy goes, because it doesn't really care. It's just there for reference. Okay, so these are ones we got cracks in. This one's quite shiny, but you can still see the PNG, so the system will learn it is the correct mark. Okay, so now we're getting into discoloration ones. And this one, I don't see the PNG well enough. I'm going to remove that. It's a bit of a lighting issue. Same thing on this one. So these are going to end up failing for a lot of reasons, including the PNG not being there or not being visible. This just has to do with problems with colorant, time of manufacturing. And this one looks like it has kind of a crack. Let's zoom in a little bit. See if we can actually see that crack. Yeah, that crack is visible on both sides of it, so let's make this crack. I could highlight this and use Control D, or I could just draw another one. Control D does copy. Let's make sure the one before this did not have cracks, and it didn't. So it looks like we just got a couple of these in a row probably, because I kind of snapped off the same picture that we'll have to call crack. Let's make sure the PNG and the plug is centered. We're almost done. Alright, we're at the end of the line. So, verified everything. All you got to do is close the program at this point. And it's going to go and verify that all the objects are properly or consistent across all images. And if not, it's going to ask you to verify. So something was inconsistent in the mix here, so just make sure plug is what we expect, hole is what we expect, PNG is what we expect, hinge is what we expect. Nest is a reference item, and both the crack and discoloration are defects, so that's all good. So then we close, and you'll be presented with the training system interface, which allows you to say if you're going to train from scratch. In this case, we are training from scratch because we're training this for the first time. So I could leave that unchecked. If I were to do continuous training, I'd want to leave that unchecked. And I'm going to go ahead and add my email address for it to notify me when it's done. If this was the very first time I was training, I would want to generate an API key out of QC Hero. So to generate an API key, what you do is you go to Settings and API Keys, expand, and then name the API key. So I've done this a couple times, so I'm just going to call this PAQi 3. I'm going to check all the API options and generate a key. And then I'm going to go ahead and copy this key and paste it into a notepad file. So just open up Notepad and save this somewhere on your machine. Once you do this once, you won't have to do it again. So I saved the original one for my previous videos to the desktop. So I was going to call this API key 3. And you want to make sure you're in UTF-16 format. So go ahead and save. You can minimize QC Hero at that point. And then you could hit the reset API key and just double click on either one of these for that matter. I've already got it set, so I'm not going to change it again. And then when I'm done with this process, I can go ahead and close. And the training will commence on its own in the background. You'll notice that you're presented with a wizard that will allow you to set up a part number for this one. So we'll call this Old Spice. We're just going to call it Old Spice Object Detector. We're going to run one step on this. We're going to enable the camera, of course. We're going to use the CapOD profile for the camera. We're going to say yes, we're going to detect. We're going to use the detector that we're training, and we're going to add a new calibration. So we're going to call this Old Spice OD Cal. So this detector Alright, so you notice that it presents me with, in my object list, all possible objects that we are training for. And in this case, crack and discoloration are both defects. So we're just going to highlight them and say they're defects. We're going to expect one hinge, one PNG, one hole, and one plug. And usually I just leave all the defaults as they are. The scores will get updated as the detector is trained and evaluated. So really that's all you have to do. Just say, I expect one plug, one hole, one PNG, and one hinge. No cracks, because a crack is a defect, and no discoloration. So if it sees either one of those, it's going to fail, even if it found the rest of these objects. So this is part good object detector plus defect detector. Go ahead and save those. It sets that as the calibration that we're going to use. Gives us an overview saying we're going to take an image. We're going to do detection on step 1, camera 1, using profile CapOD, using detector Old Spice CapOD, and the calibration Old Spice OD Cal. So I can say next. I'm going to display these on failure only. I'm going to turn off operator override. I'm not going to count production, and I'm not going to present any macros for the operator to do verification with. And that's it. So go ahead and close. The detector will train in the background, so actually if I go back to QC Hero and I look at my detectors, I can go to current jobs. This hasn't started yet. It takes a little bit to upload all the images. We can see that we have now an Old Spice CapOD detector, which is marked as an object detector, and no versions have been created yet. If I go to the training data, once everything is uploaded or starts to upload, you'll see that it's going to populate the training data and start training. So we'll give it a minute or two. But this is just for demonstration purposes. You don't need to do anything with this. The system will train the detector and complete, and then install it if it evaluates out okay. So after waiting a few minutes here, you can see that we've got 140 images uploaded, even though we only generated less than 40 or something like 40, because the system automatically augments to a higher number of images, which is just synthetically creating images of the likeness of the samples. So the training's begun. It's off and running. We've got a new part number set up here, so I can go ahead and select the new part number, which is the Old Spice OD. And if I snap pictures against it, it'll just take pictures. So you see this, the green light goes solid real quickly until the detector is actually loaded, at which time it'll start doing inspection and it'll expect one hole, one plug, one PNG sign, and one hinge that doesn't have cracks in it with no discoloration. I'm going to demonstrate how to train an object detector more. So, training button, train from production. We're working with the Old Spice OD, which is used in the CAP OD detector. So I'll go ahead and hit OK. This loads the images into the labeling program so that we can verify them, and then the detector will be trained more. So as usual, we just want to verify the labels that are presented. These would be the images that scored either with failures or low. So this is a discolored part. Make sure our labels are correct. These are the ones with the cracked hinges. Look correct. We have an empty nest. And then some more cracked hinges as well. So not very many images were presented, but that's okay. You can do as many as you'd like. So all we need to do now is just close the labeling program and the training will commence. Just keep running the station as is. For example, if I put a part in there with cracked hinges, go ahead and do a snap. You'll see that the object detector does not detect a hinge, a good hinge, and detects two cracks at 100% certainty. So this is working quite well. I go ahead and put in a good one. I go ahead, it passes right away. If you recall, we set up the part number so that it only displays the images on failure. So a good one passes. I can actually show that image, what it looks like. If I go to Manage, Machine ID Demo 1, today's date, Analysis. Let's do a little bit of sorting by time. So we're looking at the last one. And we'll see that this non-discolored good part with a good hinge has one plug at 100%, one PNG symbol at 100%, one hole at 100%, and a hinge at 100%. Perfect part. You'll also notice if I do a partially discolored part, which does not have like the big swirl in the middle, it still gets scored as a discoloration. So somewhat by coincidence, this detector has also learned the difference between color. But you really should use a classifier in that case. But this detector is capable of seeing that these parts are discolored, cracks in the hinges, and that the plug and hole are present. So let's go ahead and cover one of the holes or plugs. So, still senses this. This is a trial. It senses that the screw is still inside the plug, but you'll notice that the PNG is being covered up, so that is scoring a 0 now. So let's see if I can use something to cover it a little bit more. I'm going to kind of point a pencil at it. Now, of course, you'd really want to have some samples that have the plug blocked to train the detector properly. I didn't. Let's try that again. Okay, so now the plug scores at a reduced score. Gives you kind of an idea how this works. It can still see the barrel of the plug, but the plug isn't complete, so it ends up scoring that low. It also somewhat obstructs the PNG, so that scores low as well, causing it to fail.